Okay, hi guys. Since you were gone today, I wanted to walk through how to find the wavelength and the frequency so that we could plug those numbers into velocity and solve for that. So when we did our slinky waves, we came up with some numbers. You measured node to node. And so when you were doing your slinky, that was where it crossed the resting line. You made those marks and you measured with your ruler. And then we also measured how many times that wave crested in 10 seconds. So I have this set up with the units and everything, and then we'll plug them into an equation to find the wavelength. This is lambda. It's a Greek letter for wavelength, and then F stands for frequency, and we'll run through that too. So if I give you a sample problem, we'll go through all the numbers. I'll show you how to do the units. And then on your email, you will have 3 problems that you need to work through and show me when you're done, as well as finishing up question number 5 on page 2 in your lab binder. So first of all, if we measure node to node on a wave and we find that it equals 50 centimeters, okay, so I'm going to write 50 here. And we never write a number without including units. So 50 what? Well, it's 50 centimeters, and that's for half of a wave. So when we write our units like this, it'll be a little bit easier to show all of our work with units, and that will help us figure out the equation. So 50 centimeters per half a wave means that we only measured half the wave. Remember, you can measure node to node to node, or crest to crest, or trough to trough, and that gets you the whole wavelength, which is what we're looking for. Then for crests, how many times it crests while we were counting, we did it out of 10 seconds, okay? And the number I'm going to give you is 70, all right? So this wave is 50 centimeters from node to node. It crests 70 times in 10 seconds. All right, so first let's figure out lambda, or the wavelength. To find the wavelength, we find the equation within our units. It is centimeters. This line means per, or in a, or every time each wave. So this is centimeters per half a wave. That line means division. So mathematically, what we're going to end up doing is we're going to take 50 centimeters divided by half of a wavelength. And it looks like this. I will set it up 50 centimeters divided by 0.5 waves. Okay? And so if we do this mathematically, 50 divided by 0.5 actually ends up being the same as 50 times 2. So when we're dealing with decimals and we're dividing by decimals, it actually means that we double that number. So 50 times 2 is 100. So that equals 100. And then for our units, we take a look at what we have left. It is centimeters per waves. So this wave is as big as 100 centimeters each wave. Okay, now for frequency, again, we look to our units to figure out what we're going to do. We have 70 waves every 10 seconds. This line, again, means in a, or per, or each. Okay, 70 waves every 10 seconds, each 10 seconds, per 10 seconds. And this line also means divide. So we're going to set up our equation like that. So we take 70 waves, and we divide it by 10 seconds, okay? And 70 divided by 10, if you think about your tens, when we're dividing by it or multiplying by tens, we can just move the decimals, so we don't need any calculations with the calculator. So I'm dividing it by 10. I'm going to make this number smaller. I'm going to move the decimal back one space. Our answer ends up being 70. And we need to include units. Our units are right here. 70 waves per 1 second. So we do waves per second. All right. And now we have our wavelength and our frequency. And so now I always say plug and play. What you need to do is you need to look at your equation. So that's right here. Velocity equals lambda, that's wavelength, times f, that's frequency. And so by plug and play, what I mean is I take the number we solved for this, which is 100 centimeters per waves. Notice I'm including units. Always include your units. So 100 centimeters per waves. Okay, and I write that here times frequency. Okay, and we solve for frequency. It was 70 waves per second. So this is how I'm going to write it so that our units will help us figure out the velocity. So I'm going to go, this was 100, and it was centimeters per 1 wave. And then I multiply by 70, and this was waves per second. That's 1 second, okay? And so if we do this, okay, we have 170 and 1 and 1, and when we multiply in a fraction, we're just multiplying across and multiplying across. So it's 170, which ends up being 700. So my number is 700, but then I got to figure out the units. So if you remember from math class, if I write it like this, centimeters over waves times waves over seconds. All right, do you notice the waves down here and the waves up here? We can cross simplify. The waves will cancel out and just turn into ones. And what you're left with is your units. Centimeters goes on top, seconds goes on the bottoms. So you end up with centimeters per second. I'm going to erase this here. Centimeters per second. To see that up here, we have these waves here, cancels out and cancels out. And then we have 100 times 70 centimeters over seconds, centimeters per second. Now that probably sounds a lot like speed, right? You cover a distance in a certain amount of time. The distance is in centimeters, and you do that per 1 second. Okay, it's a lot like miles per hour, or like 100 meters in 14 seconds, which will give you your speed for the 100-meter dash if you're that fast. So here we end up with 700 centimeters per second. So why do they call it V? Why do they call it velocity? Well, velocity is a speed, but it's a speed that includes direction. So if I say I was traveling to work this morning and it was speeding a little bit, and so I was going 68 miles per hour on Highway 20 in order to get to work on time, and then I said I was westbound, okay? That's speed with a direction. And all the waves we're going to deal with have a direction, so we'll refer to them as velocity. Now go ahead and do the 3 problems that are included in the email, and come see me when you're done. Thanks.